Hello everyone, here are the solutions to yesterday's worksheet. I have a separate PDF showing each step, so be sure you look at that attachment and let me know if you have any questions. You can pause the video so you could check them, or you could just check out the PDF, which you have to anyway as you want to correct your answers. All right, so today we're going to look at inverse functions. So I have another PDF. If you wish to print this out, you can, so you're not writing all of this down. So at the very top of this, we just have some definitions. So we're just going to write in some examples. So at the very beginning of the school year, we took a look at a relation and what a function was. So a relation is any set of ordered pairs, and it looks like this. We just have a set of ordered pairs. So it could be anything. It could be a 2, 3, a -1/2, and a radical 5, a 0, and a -6. Again, just any list of ordered pairs in the set brackets. A function, though, is a special kind of a relation. It's one in which each first coordinate is used only once, or in other words, all the x values are different. We've talked about domain and range before. The domain is a set of all the x values, the range is a set of all the y values, and a function passes a vertical line test, meaning if a vertical line passes through a function once, or passes through a relation once, then it is a function. So what's new is now an inverse of a relation, and it shouldn't be new to you. You should have seen this back in Algebra 1 and in Algebra 2. An inverse of a relation is formed by interchanging the first and second coordinates of each ordered pair in the relation. So in other words, we say just switch the x and the y coordinates. So here we're given a relation. We're just going to call it capital M, and it's just a list of ordered pairs. Which answers our first question. Is this a relation? Yes. It's a set of ordered pairs. Is it a function? Well, let's take a look. Are all the x's different? Yes. We want to form this notation here. M to the negative first means the inverse of M. So let's write this off to the side. The inverse of M is written like this, M to the negative first. So we want to form this just by switching. So M, the inverse of M, is going to be the set, and we just switch the x's and y's. So if we're looking at a 2, -7, we write a -7, 2. 4, 0, we're going to write a 0, 4. 1, -7, we write a -7, 1. Now is the inverse of function. Let's take a look at our x values. Looks good so far, but then right there, no. -7 repeats. So again, the domain is the list of all the x values. So we want to go back up to M. The domain is just the list of the x values, 2, 4, and 1. We could put it in order, 1, 2, and 4. What's the range of the inverse? So let's take a look at the range is all the y values. If you take a look, we have a 2, 4, and a 1. Put it in order, we have a 1, 2, and 4. And that's not a coincidence. Because we're switching the x's and y's, the domain of our function is going to match the inverse, or the range of our inverse. So next we're going to take a look at how to algebraically find the inverse of a function. Now this is not part of the handout, so if you want to write this on your own sheet of paper, just at the bottom of the first page. So here our function is f of x is equal to 5x minus 7. Step 1. Now if it's ever given to us in f of x, we use step 1 here. We're going to replace f of x with y. If it already has a y, we don't have to do this. So now our function becomes y equals 5x minus 7. Step 2 is that we switch x and y. So now this says x equals 5y minus 7. Step 3 is we solve for y. We want to do that by adding 7, so we'll get an x plus 7 equals 5y. Divide by 5, so y is just going to equal x plus 7 over 5. Then really our last step is to replace y with the notation for the inverse. So we would have f to the -1 of x. So now our inverse that looks like this is equal to x plus 7 over 5. So now I just want to show you, eventually you're going to be able to do this on Desmos, but if we were to graph y equals 5x minus 7, and then technically y equals x plus 7 over 5, this is what we're going to get. So what's in this kind of a hot pink or light purple color right here, that's our function. What's here in green, that's our inverse. And then what's happening here, this is the line y equals x. If you take a look here, I have the point 1, negative 2 right here. If I were to switch that around, negative 2, 1, that shows up on the inverse. And it's reflected over this line, y equals x. So graphically, a function f and its inverse are symmetric with respect to the line y equals x. So we know they're going to be inverses if they are symmetric with respect to the line y equals x. Or we could say that they reflect. F and its inverse are going to reflect over the line y equals x. All right, so now we're going back to that handout. We're going to try a few problems from it. So we're first going to take a look at number 1. And again, this is why I prefer, if you can print it out, please do so, because you're going to need this little coordinate plane. So for 1a, we want to find the inverse algebraically. So we're going to start going through those 5 steps. First, I start, instead of f of x, we're going to say y equals 1/2 x minus 2. Replace f of x with y. Next, we're going to switch x and y. So we get x is equal to 1/2 y minus 2. Then we want to solve for y, so we'll add 2. We'll get x plus 2 is going to equal 1/2 y. I'll continue over here. Then we solve for y. Our next step would be to multiply everything by 2. So I could have 2 times x is 2x. 2 times 2 is 4. So y is going to equal 2x plus 4. So to finish this, this is now going to be the inverse of f of x is equal to 2x plus 4. So now we're going to graph these here. I'm going to highlight this one, make that in blue, and I'll put this one in green. So if I go to graph y equals 1/2 x minus 2, I'm going to go down to negative 2 for my y-intercept. My slope is 1/2, so I'm going to go up 1 over 2, up 1 over 2, and then we'll draw a line. And we want to label this, that this is f of x. And then for my inverse is going to be up at 4, and I have a slope of 2, so I go up 2 over 1 or down 2 over 1, and I'll continue this until they intersect, and just be very careful. They need to intersect very specifically here. So now we're also going to graph, this is what we're getting ready for B. We graph both our function and its inverse and the line y equals x. I always like to draw this as a dashed line. So I'll put this in red here. So y equals x just goes right up through the middle, and we should see that our functions should reflect over this. So this is our inverse function. So if we took a point, say we took a point right here, that's the ordered pair negative 2, 0. And then if I flip it, I should be at 0, negative 2, and here's that point right here. So that's a nice way to check. Another way is by composition of functions. So we want to compute and show all steps. So this becomes f, this is the notation we saw yesterday. So just rewriting this, this becomes f. My inverse was 2x plus 4. So now I'm going to substitute this right up here to 1/2 x minus 2. So I'm going to get a 1/2 times the quantity 2x plus 4 minus 2. Now what should happen here is everything should cancel because they're inverse operations, and we should be left with an x, but we have to show it. So half of 2x is just x, half of 4 is plus 2, then a minus 2, so we're just left with x. Just the opposite here, we are going to take our function 1/2 x minus 2 and put it into the 2x plus 4. So instead of trying to rewrite this, or we can say it's the inverse of f of 1/2 x minus 2. So now this becomes 2 times the quantity 1/2 x minus 2 plus 4. Again, I'm just putting that into the inverse function. 2 times 1/2 x is x. 2 times negative 2 is a minus 4 plus 4. So then this gives us x. So this is what we want to conclude. Since, and I'm just using this notation right here, f of our inverse is equal to this right here, the inverse of f of x, or f of x substituted into the inverse. They're both equal to each other and they both equal x. They are inverses. All right, we'll try a couple more here. We're just going to look at graphs. So if you go to the last page, we're going to take a look at number 4. So here this says, given the graph of f, graph the inverse of f on the same pair of axes, and then is the inverse of function explained? So what we need are some nice points here. So this is a parabola. I'm going to make a point at the vertex. If I count over 1, down 1, that looks good. If I count over 2, down 1, 2, 3, 4, that looks good. So that might be enough of points. Let's go to the very end, though. If I counted over 3, I should be able to count down 9. So that looks good. So I'm going to make a list of ordered pairs for f of x. So right here, I've got 4, 1. Right before it, I've got a 3, 0. Right after it, I have a 5, 0. Right here, I've got a 2, negative 3. On the other side, I have a 6, negative 3. Down here, I have a 1, negative 8. And then I have a 7, negative 8. Then we're just going to switch for the inverse. So this will just become a 1, 4, a 0, 3. We just switch the x and y's, a 0, 5, a negative 3, 2, a negative 3, 6, negative 8, 1, and negative 8, 7. So we'll plot these points. So here's 1, 4. Here's 0, 3, 0, 5, negative 3, 2, negative 3, 6, negative 8, 1, and negative 8, 7. And then we look like a sideways parabola. So this would be our inverse. This is f over here. There's our inverse. Then it says, is the inverse a function? So would it pass a vertical line test? No. So the inverse is not a function. And if we look over here, we've got repeating x values, the 0s, the negative 3s, and the negative 8s. Let's try one more. Number 5. Again, we want to put nice points on this. So it looks like we can go here, here, the x-intercepts as well, the maxes and mins. Got quite a few points here. I'm not going to list these out. We could just start. This would give us a negative 8, negative 4. So we have a negative 8, negative 4. So if I switch this around to a negative 4, a negative 8, I'm up here. Here I have a negative 6, 0, so I would be at a 0. Hang on, let me replot that one. This was a negative 8, negative 4. So we need to go negative 4, negative 8 down here. Next, I'm at a negative 6, 0, so we want a 0, negative 6. Here I'm at a negative 4, 4, so we want a 4, negative 4. Then I'm at a negative 2, 0, so we want a 0, negative 2. This point right here is at a 0, negative 4, so we want a negative 4, 0. Next, we're at a 2, 0, so we want a 0, 2. 4, 4 is going to stay the same. 6, 0 means we want a 0, 6. And then 8, negative 4 means we want a negative 4, 8. So this might be helpful if you turn your paper to the side. But we want to create the same curve going through this. So this is going to start to look like, just as this starts to go up, this will go up through here, turn, kind of come back down through here, turn, go back up, turn, and then come back down. So this is our inverse. Again, not a function. We have quite a few repeating x values. Will not pass the vertical line test. All right, so what I want you to do is use the examples we did and finish this handout. We will do more tomorrow.